Good day. This video will cover the final our complex or general annuity series. So in this video, we will be covering complex or general perpetuities. So before I start, let me turn off my camera para di mag-ilog ang enhanced signal. Okay, so let's start. So for complex perpetuities, let's go directly to the how do we, what symbol should we use? Complex perpetuity. Should we just use that? Okay, yeah, let's use that. Okay, so CP, complex perpetuity. So in your reference book, the formula that was illustrated or that was given is this one. Payment is equal to payment. Complex perpetuity is equal to payment, and then design payment over I, and then it's multiplied by the fraction. So that's 1 over that's another fraction, and we start with this one. So that's 1 plus I, and then we raise that to C, and then minus 1 over I. Okay, so to simplify this formula, we can invert this, and then it will now become 1 plus I over 1 plus I to the power of C minus 1, or simply this one. Be that one. Okay, so after this, we can now cancel out I, which gives us the final formula for our complex perpetuity, which is payment over 1 plus I to the power of C minus 1. Okay. So with this formula, let's go directly to a sample problem. So, by the way, before we proceed, my formula for this is this one. Yeah. Insert. By the way, there is this so complex ordinary perpetuity. Okay. So this one CP is equal to design payment over IE. So this will be my formula. Now let's go directly to the sample problem given. Excuse me. Okay. Find the present value of a perpetuity of 500 pesos payable semi-annually if money is worth 6% compounded monthly, and the first payment is due 6 months hence, and first payment is due now. Okay. So find the present value of perpetuity. Okay. Hmm, First, this is first. Okay. So now, if our relevant data would be our payment is 500, and our INOM is 6%, which gives us an I of compounded monthly. So that would be 6% over 12. And then our C here is again, C is how do we define C? So this is number of months per payment period over the number of months per compounding period. So how many months are there in our payment period? So our payment period is semi-annually. So that's 6 months. And then our interest number of months per compounding period is monthly. So that's 1. So our C is 6. So with that, if we substitute our given information to our formula, okay, so this will be our payment is 500. Mm, Payment is 500. P. And then our I is 0.005. Our C would be 6. Okay, so this should give us a value of 500 over 1 plus 0.005 raised to the power of 6 minus 1. 16, 459.55. Okay, okay. So now, if we use my way of solving things, which maybe some of you will find this a lot longer, but it's just that I like this one better. At least I'm showing you another way of solving these problems. So original compounding periods is that would be so some no original compounding periods would be monthly, and then we transform that into semi-annually. Okay, so our I here is 0.005, and our M here is monthly, so that's 12. Okay, so our value should be, oh, sorry. Okay. Mhm. Okay. I shouldn't have put that directly. Sorry. So this is okay. So if we solve for this should give us, oh yeah, 1 plus 0.005 raised to the power of 12 minus 1. Okay, and then for our second formula, we know that our I is unknown, our M is 2 because this is semi-annual, okay, minus 1. And then for the next part, we substitute IE2 with 0.06168, which is, it would be helpful if you would use the unrounded off uh, value, making it necessary for you to use your store function. Okay, so next would be, okay, I'm just gonna insert an equation here. where are you going? Okay, so yeah, so we have A1. Okay, so we have A1 plus I raised to the power of 2, and then plus 1 plus 0.061678. Okay, because our 1, we just transferred that to the other side. So it's not, it now became 1 plus 0.060167 And then for the last part, and then we're gonna insert another equation. Okay, so I now is equal to our radical sign. Okay, so that would be square root of 1.0616, aray ko, 1.061678. Then outside of that we deduct 1. Okay, now because we transferred the squared here, square to the other side. Now it becomes a square root, and then of the sum of these two, and then we transfer the positive 1 to the other side, so that it now becomes negative 1. Okay, so with that, if we solve for it, this should give us a value of 1.061 plus over this one, and then we raise that to 1 over 2, and we deduct 1. Okay, so this is now our equivalent interest rate per period. So if we replace that here, okay, our payment is 500, and our equivalent interest rate is 0.06 0.0378 0.030378. So if we compute for that, this should give us 500 divided by our equivalent interest rate per period, which, wait lang. Let me solve for this again. Bakit may discrepancy na piso? Maybe I just typed it wrong. Yeah, it's 1459.55. Okay, so the answer is still equal. Okay, whether you use my formula or my way, or the formula that was given to you by the book. Now, what if it is a complex perpetuity due, OCPD? So for that, we simply have to use this formula, and we add the first payment to that. Okay, so with that, or we can simplify this into common payment. So we'll have 1 plus okay, so we multiply it like that. Okay, so now with this, your final formula for your complex perpetuity due would be this one. Payment time, because payment divided by payment is 1 plus payment, this one divided by payment would be makancel si payments, mabilin si 1, and then the denominator will be the same. So with that, you will get 16,959.55. While if you would use my formula, which is simply this one, and then we add payment from we add the very first payment, and then if you would simplify this formula, it would look like this. Payment multiplied by 1 plus 1 over IE. The concept is still the same, you know. Payment divided by payment would be 1, and then payment over IE divided by payment would be 1 over IE. So if we solve for that, then it would be 500 plus, uh, we multiply that by 1 plus 1 over our uh, equivalent rate. Okay, so with that, we still arrive at the same answer. So with that, guys, we're done with our chapter 10 discussion. Hopefully that you have learned something from this. And when it comes to manipulating the formulas from part 1 to part 3 of our series, I hope that you would do that yourselves, because I know that you can do it. I have already trained you on that. If you want to recall on how to transform formulas, for example, when payment is unknown, or when the interest rate is unknown, things like that. So you may go to our previous videos on our discussions and annuities, where our formulas, on how to, or the transformation of formulas were discussed. Okay. So again, guys, thank you so much for listening, and I hope that you have learned something from this. See you on our discussion for chapter 8, which will cover depreciation. So and for that last series of videos, that will be the end of our discussions for this semester, and then prepare for post tests, and then submit your chapter summaries and chapter assignments, and we'll have to prepare for your final exam. So again, guys, thank you so much for listening, and I'll see you on the next videos. Thank you. Bye.